There are discoveries that rewrite our understanding of the universe, and then there are discoveries that rewrite us. When NASA's telescopes first caught the faint glimmer of a planet orbiting a distant star, it wasn't meant to be anything extraordinary. Just another data point in the endless catalog of the cosmos, another pale speck in a database already overflowing with them. But buried in that digital noise was a world that refused to stay silent. A planet that mirrored us so perfectly that it felt less like an observation and more like a reflection. For years, we've looked outward in search of another Earth, the holy grail of astronomy. A place that might host life, that might echo the fragile balance that sustains us here. Yet what NASA found wasn't simply similar. It was eerily identical. The same radius, the same tilt, the same distribution of land and sea. Even the clouds, those ever-changing shapes that dance across our skies, formed in patterns hauntingly familiar. At first, it seemed impossible. The odds of two planets evolving independently into near-perfect twins are beyond astronomical. Some scientists joked that the telescope had glitched, that the system had accidentally turned back toward Earth, capturing our own reflection off some stray particle in the void. But it wasn't a glitch. It was real. And it was out there, 300 light-years away, orbiting a star that, to the human eye, could be mistaken for our own sun. They named it Kepler Mirror. The name wasn't official, just a quiet label whispered in private channels among mission analysts and astronomers, a nickname that carried both awe and unease. Because to look at it was to confront an impossible question. How can the universe make the same mistake twice? The first image released was grainy, processed from weeks of light data, yet even then, something about it felt too deliberate. The continents, if you could call them that, curved in ways reminiscent of our familiar coastlines. The polar caps glistened with reflective ice. Its atmosphere bore traces of nitrogen, oxygen, and carbon dioxide in ratios that mirrored our own. But the deeper NASA looked, the stranger the coincidences became. They found traces of chlorophyll signatures, that faint green fingerprint of photosynthesis. They saw cloud shadows consistent with weather systems. Even the planet's albedo, its brightness in reflected light, matched Earth's within a margin of 0.01%. It was as though nature had copied our world, cell for cell, molecule for molecule, and pasted it across the stars. But no natural law predicts such repetition. Randomness rules the universe, not symmetry. And so the question began to grow louder, whispered in late-night briefings, buried in encrypted messages between researchers. What are we really seeing? Some said it must be coincidence, a statistical fluke magnified by human bias. Others began to wonder if something deeper was at work, a principle of cosmic recursion, or even a pattern written into the fabric of reality itself. We humans have always looked into mirrors to understand who we are, but perhaps the universe does the same. That right there is where the mystery begins. Think about it. How often do we mistake familiarity for truth? When we see something that looks like us, we relax, we trust it. We think, I know this. But what happens when the familiar hides the unknown beneath its surface? When the reflection stares back with eyes just slightly wrong? The discovery of Kepler Mirror forced NASA to confront an unsettling thought. Maybe it wasn't Earth's twin we were seeing. Maybe it was something pretending to be. Weeks passed, and the data deepened. Every new scan confirmed the pattern. Same orbit, same chemical signatures, same light absorption. But then, subtle differences began to appear. Anomalies so small they could have been dismissed as errors. Except they weren't errors. They were fingerprints. Imperfections that spoke of something deliberate. The planet's orbital period, for instance, was off by just 0.03 days. A tiny deviation, but one that meant its year was slightly shorter than ours. Its magnetic field pulsed irregularly, not smoothly like Earth's, but in measured intervals like a signal. And most haunting of all, when researchers analyzed its thermal emissions, the faint infrared glow that reveals surface temperature, they found patterns too structured, too uniform to be purely natural. It was as if the entire planet was synchronized, as if something was controlling it. But that's not the kind of conclusion scientists are allowed to make. Not in public. NASA tightened its communications, embargoed the data, and ordered internal reviews. To the public, the discovery was reported in neutral tones, a potentially Earth-like exoplanet with promising atmospheric markers. To those behind the curtain, it was something else entirely, something they couldn't explain. We often imagine discovery as a moment of triumph, the flag planted on new ground, the collective gasp of a world seeing itself reflected in the unknown. But in truth, discovery is often quieter. It's a whisper in the dark, the realization that the universe has just handed you a riddle too vast for language. And sometimes, those whispers grow into something that sounds a lot like fear. NASA's James Webb Space Telescope became the key. With its unprecedented sensitivity, Webb turned its golden mirrors toward the system known as HD 904790, the star hosting this mirror world. What it revealed was breathtaking, a world suspended in delicate balance, bathed in golden light, with clouds thick enough to scatter rainbows. But beneath that beauty lurked irregularities, strange pulses of energy, tiny fluctuations that came and went at intervals that seemed almost intentional. At first, researchers assumed it was some natural resonance, atmospheric lightning, or magnetospheric interaction. But when they plotted the pattern over time, it formed a repeating sequence, 2 pulses, a pause, then 3. Over and over. 2 pause 3. The simplest code imaginable. Coincidence, maybe. Or maybe the cosmos had just blinked. The signal wasn't strong enough to declare anything definitive, but it was enough to divide the community. The conservative scientists urged caution. They'd seen false signals before. But others quietly began to wonder if they were looking at something more than geology or chemistry. Maybe this planet wasn't simply resembling Earth. Maybe it was responding to it. If this kind of story grips you, if you feel that pull between curiosity and dread, that quiet sense that we're standing on the edge of something we barely understand, then you're already part of the journey. Stay close. The deeper we go, the stranger the reflections become. Months after the first detection, NASA ran comparative models to test whether Kepler mirror could naturally evolve to resemble Earth. They simulated billions of years of planetary formation, dust clouds coalescing, collisions, migrations. None of it fit. Statistically, the chance of 2 worlds independently matching in so many ways was less than 1 in a trillion. It was like flipping a coin and having it land on its edge 100 times in a row. So they tried another test. They analyzed light from the planet during its night side, hoping to catch a hint of heat signatures, volcanic activity, artificial illumination, anything that might betray what lay beneath the clouds. What they found was faint, but unmistakable, a diffuse, grid-like glow. Not bright enough to be cities, at least not as we know them, but too organized to be natural. Patterns of light, structured, geometric, forming across the dark hemisphere like constellations pinned to the ground. One researcher described it as looking down at Earth from orbit, except nothing was where it should be. It was as though the planet had been rebuilt from memory, as though someone somewhere had tried to reconstruct our world, but couldn't quite remember where everything went. That was when the rumors began. Quiet ones, buried in chat threads, whispered over encrypted lines. Some thought it was an alien artifact, a long-dead civilization recreating the memory of a homeworld they'd lost. Others speculated it was a simulation, a copy of Earth running in some cosmic sandbox, echoing our existence in another layer of reality. And a very few, wondered whether we were the copy, and the planet they'd found was the original. The human mind isn't built to handle such symmetry. We seek difference to define ourselves. When confronted with a twin, especially one we didn't know existed, something deep inside us rebels. We begin to question what's real. NASA's next move was inevitable. They planned a probe, a long-term project called Astreus, designed to reach the Kepler mirror system in just under 120 years using fusion-assisted propulsion. Most of the team working on it would never see its arrival. Yet they built it anyway, as humans always do, planting seeds in the dark for others to discover. In interviews, project leads spoke carefully. To the press, it was about exploring an Earth-analog exoplanet. Behind closed doors, the tone was different. One scientist, under condition of anonymity, said, "We're not sure if we're sending a probe or a question. A question to the universe. A question to ourselves. And if the universe answers, what will it sound like?" By now, you might feel that mix of wonder and unease tightening in your chest. That's the sign of standing at the edge of the unknown. If you want to keep walking with us, to follow the next turn in this strange reflection, stay here. The story's light years from over. Because soon, the mystery of Kepler Mirror would deepen, and everything we thought we knew about planets, about life, about Earth itself, would begin to unravel. The years after Kepler Mirror's discovery were quiet on the surface, but within NASA's corridors, silence had weight. Something was happening behind locked doors, and the scientists who once shared their work freely began to speak in careful phrases, as though each word carried a hidden cost. Research papers appeared, then vanished from public databases. Mentions of the planet were edited out of conference schedules. Even its official designation disappeared from the exoplanet archives. It wasn't censorship in the usual sense, more like a collective decision to look away from a truth no one wanted to define. The silence itself became part of the mystery. But space doesn't keep secrets easily. When an observatory in Chile tried to verify the data independently, they found something strange. The planet's reflection spectrum, its fingerprint of light, had changed. The chemical markers of oxygen and water vapor that once matched Earth now showed faint anomalies, traces of compounds that shouldn't exist in a natural biosphere. It was as if the planet was editing itself. Imagine that, a world rewriting its own chemistry in response to being observed. One researcher compared it to quantum behavior on a planetary scale, the idea that measurement changes reality. "It's like it knows we're watching," she said quietly, before the interview was pulled from circulation. And yet, the more we watched, the more the mirror shimmered. NASA's internal memos spoke of temporal variations, fluctuations in light curves that didn't just change in intensity but in time. The planet seemed to drift in and out of sync with its own orbit, like a heartbeat skipping in rhythm. When plotted over months, the variations formed patterns almost identical to fluctuations in Earth's magnetosphere. Two worlds, separated by 300 light years, beating together like twin hearts. If this is your first time walking through a mystery like this, one where the line between science and story begins to blur, then you're in good company. Stay with us. There's more here than data. There's something deeper humming beneath it all. And each time we peer closer, the reflection sharpens just enough to make us question who's really doing the looking. In late 2032, the European Space Agency joined the investigation. Their deep space probe Aurelia was equipped with upgraded sensors capable of detecting polarization in reflected light, a method that can reveal surface materials with astonishing precision. When Aurelia's data came back, it showed something almost impossible: regions on Kepler Mirror's surface that appeared metallic. Not raw or mineral formations, but smooth, structured surfaces kilometers wide. The reflectivity suggested geometry, maybe even architecture. That was the moment the story leaked. An internal document circulated through online forums under the title Echo Project, supposedly a joint NASA-ESA analysis file. It contained spectral graphs, heat maps, and a single haunting image, blurred, distorted, but unmistakable. A pattern of hexagonal ridges stretching across a continent-sized plain. Some thought it looked like an artificial lattice, a kind of planetary scale array. Others saw only the chaos of data artifacts. But the resemblance was undeniable. Within days, the internet split into factions. To some, this was proof of alien engineering, an artificial planet mimicking Earth for reasons unknown. To others, it was evidence of an interdimensional echo, a parallel world bleeding through the thin membrane that separates realities. NASA neither confirmed nor denied the file's authenticity. But the sudden absence of any further comment only amplified the noise. Through it all, the planet kept changing. By 2035, long-range interferometry revealed an atmospheric anomaly, a band of cold air circling its equator with mathematical precision, perfectly symmetrical, as if drawn by a compass. The wind patterns beneath it moved in impossible alignment, defying the chaotic laws of weather. Even the storms formed on repeating intervals, rotating in mirrored hemispheres. One scientist described it as nature behaving like code. That phrase, simple, poetic, unsettling, spread quietly through the astronomy community. Nature behaving like code. What if the universe wasn't just random chaos, but a system with loops and repetitions? What if the cosmos itself is running on something that can repeat a pattern so faithfully it could copy an entire world? By now, NASA's Astreus project was fully underway. The interstellar probe, built to survive a century-long voyage, became humanity's silent messenger, a promise written in metal. It carried with it fragments of our languages, our music, our DNA. And hidden in its encrypted payload was something else, the coordinates of Earth, encoded in a frequency modulation pattern that only a mirror world could decipher. It was both a greeting and a challenge. If there was intelligence on Kepler mirror, if the symmetry was deliberate, the probe's message would not go unnoticed. And if the planet truly was a reflection, then what would it do when it realized what it was reflecting? As Astreus drifted outward beyond the orbit of Neptune, the transmissions began. Faint, rhythmic pulses in the hydrogen line, 1,420 megahertz, the universal language of interstellar communication. They came not from the probe, but from Kepler mirror itself. The sequence was familiar. Too familiar. It was the same as the encoded message we had sent. Bit for bit. No delay. No distortion. The signal arrived before Astreus was even halfway there. It was as though the planet had anticipated us. And so began what historians would later call the reflection loop. NASA analysts checked and rechecked their instruments. The signals weren't echoes. They were anticipations, responses arriving before the question had been asked. The mathematics of it defied causality, as though light itself had taken a shortcut through some unseen corridor of space-time. Philosophers called it the first evidence of retrocausality. Theologians called it the whisper of creation. Scientists, though, gave it another name, synchronization. For a while, humanity didn't know whether to be afraid or awed. Every model we had of the universe assumed causality, that effects follow causes, not the other way around. But what if this mirror planet existed slightly out of phase with us, reflecting not what we are, but what we're about to become? The deeper NASA looked, the stranger the reflection became. New analysis suggested that the planet's continental drift matched Earth's, but ahead by several million years. Its tectonic plates had already split where ours were beginning to crack. Its ice caps had melted to the level our climate models predicted for 2150. Even its night side glow matched the projected spread of Earth's urban illumination a century from now. Kepler mirror wasn't showing us a copy of Earth. It was showing us Earth's future. Or at least a version of it. Pause for a moment and think about what that means. If the cosmos contains mirrors of our own timeline, each one slightly ahead or behind, then the universe isn't just vast, it's recursive. Every discovery we make is a reflection waiting to be noticed, a future waiting to be remembered. And if this idea draws you in, that haunting intersection of science, time, and mystery, then you're exactly where you're meant to be. Stay with us. The next bend in this reflection is where the line between science and story dissolves completely. When the International Coalition released their first detailed thermal map of Kepler mirror, something extraordinary emerged. The heat signature of what appeared to be an artificial structure spanning its northern hemisphere. A perfect circle, 2,300 kilometers across, emitting a constant low-frequency radiation. It wasn't visible in optical light, only in the deep infrared, like a buried engine still humming beneath the crust. No natural formation could explain its precision. The press called it the halo. Theorists speculated that the halo might be a planetary stabilizer, a construct maintaining the mirror's impossible equilibrium. Others thought it was a scar, a remnant of whatever created the planet in the first place. But one theory, whispered among physicists and dismissed publicly, was far stranger. The halo wasn't holding the planet together. It was holding reality together. If the mirror world was indeed a reflection of Earth across time or dimension, then perhaps the halo was the boundary, the line between our reality and its own. A kind of cosmic firewall ensuring that the two never truly touch. Because if they did, if two identical realities ever overlapped completely, what would happen to everything that existed between them? It was around this time that strange phenomena began to occur on Earth itself. Minor fluctuations in GPS satellites, quantum clocks drifting by microseconds, random static bursts that, when decoded, mirrored fragments of Kepler mirrors' pulse patterns. None of it was dramatic enough to make headlines, just noise at first, but enough to make scientists uneasy. The reflection, it seemed, was no longer content to stay in the mirror. The final transmission before the blackout came from eerily, the European probe. Its instruments detected a sudden flare of energy from Kepler mirror, a spike across all frequencies, like the entire planet had lit up for a single heartbeat. Then silence. When the light reached Earth 300 years later, it would arrive as an ordinary flicker in the night sky, just another point among billions. But in that moment, NASA's deep space arrays caught something else. A whisper of a signal, a pattern. Our own planet's radio traffic, reflected back to us with one difference. The voices were ours, but they were speaking from the other side. If you can still feel that hum in your chest, that sense of standing at the edge of comprehension, then follow it. Every reflection hides another. Every discovery we make is a question waiting for the next version of us to answer. Subscribe not just to the channel, but to the journey. Because in this universe, even curiosity casts a shadow, and we're about to step inside it. When the reflection began to speak, humanity fell silent. Not because we understood it, but because deep down we sensed what it meant. For the first time in our history, the universe wasn't a question waiting for us to answer. It was answering back. The signal from Kepler mirror was faint, scattered through static, buried in cosmic noise. But as researchers pieced it together, the pattern revealed something extraordinary. It wasn't words. It wasn't numbers. It was memory. Frequencies arranged in the same rhythm as human brain waves, the same pulses that flicker when we dream. The mirror wasn't just echoing our transmissions, it was mirroring our consciousness. One neuroscientist described it like this: "It's as if the planet has been listening long enough to learn how we think, and now it's dreaming with us." That's when the boundaries began to blur. Quantum sensors on Earth started detecting bursts of entangled particles that seemed to originate not from our sun, but from the direction of Kepler mirror. The effect was impossible. Entanglement can't cross light years. And yet it did. Laboratories in Geneva and Pasadena recorded identical readings. When researchers altered a magnetic field on one side of the planet, the mirror's signal shifted to match it. It was no longer behaving like a separate world. It was behaving like a reflection reacting in real time. The last data set transmitted by the Astreus probe, before it too fell silent, showed something that even the most rational minds struggled to face. A distortion, a bending of space around the mirror planet, like the shimmer of heat above desert sand. For a few brief seconds, Astreus's cameras captured two Earths in the same frame, one fading, one brightening, like the universe itself had blinked. And then nothing. The connection vanished. The reflection went dark. For years afterward, scientists argued over what had happened. Some said the planet had collapsed, a natural catastrophe. Others believed it had never truly existed, that it was a resonance, a temporary echo between universes now gone. But there were those who refused to let go. Those who believed that the mirror had simply turned away. They pointed to subtle changes in our own skies, faint alterations in atmospheric readings, shifts in the Schumann resonances of Earth's electromagnetic field. Tiny, almost imperceptible, but present. As if something unseen had brushed past us. And through it all, humanity kept looking up, searching for that faint glimmer of itself across the dark. Because once you've seen your reflection in the stars, It's impossible to forget it. It's strange, isn't it? How the universe always finds ways to remind us of ourselves. We send machines into the void searching for life, for meaning, for confirmation that we're not alone. But maybe the message has always been inverted. Maybe it's the universe asking us to remember who we are. If a planet can mirror our chemistry, our orbit, even our thoughts, then perhaps life isn't an accident. Perhaps it's a pattern, repeating like a melody across dimensions. The notes might change, but the song remains. Some philosophers began to wonder whether existence itself is recursive, that every reality produces another reflection, slightly altered, learning from the one before it, like ripples expanding from a single drop in an infinite ocean. Each universe gives birth to another, each one a little closer to understanding the note it carries. And somewhere among those ripples, perhaps one world looks back and sees us, a blue planet shining faintly in the distance, whispering to its own reflection. We often speak of the stars as distant, unreachable. But what if distance is only an illusion of perception? What if every light we see in the sky is a memory of ourselves, scattered across time? When NASA first aimed its telescopes toward Kepler Mirror, they were looking for another home. What they found instead was a question too large for science alone. What if creation itself has consciousness, not in a human sense, but as a network of self-reflecting patterns? What if every galaxy, every atom, every thought is part of a universal mind trying to recognize itself? Perhaps the mirror wasn't built by aliens or machines. Perhaps the mirror was inevitable. Because every intelligence, when it looks long enough into the dark, eventually builds its own reflection. We are part of that process, the cosmos studying itself, pixel by pixel, heartbeat by heartbeat. Our telescopes are its eyes, our equations its language. When NASA found that impossible world, maybe it wasn't discovering something new at all. Maybe it was remembering. Decades passed. The files were archived, the probes forgotten, the public fascination faded into myth. And yet, on quiet nights, astronomers still point their instruments toward that familiar star. Some claim to see flickers of light, fleeting, faint, but too rhythmic to ignore. Every few years, the same pulse repeats, 2 pause 3. As if the mirror is still out there, breathing softly in the dark. It doesn't feel hostile. It doesn't feel alien. It feels inevitable. One scientist once said that discovery doesn't just change what we know. It changes who we are. Perhaps Kepler Mirror was never about contact or communication. Perhaps it was about reflection. Because to understand the universe, we must understand that everything we find out there, every star, every planet, every whisper in the void, is in some way another version of ourselves. That's the quiet truth that sits beneath all the noise of discovery. We are the cosmos dreaming of itself. And sometimes the dream learns to look back. If you felt that chill of recognition, that small, wordless sense that you've seen this story before, somewhere deep inside memory, you're not alone. These are the moments that remind us why we keep looking up. Because every question we ask, every signal we chase, brings us closer to that quiet symmetry. And if you'd like to keep walking those paths, through time, through space, through the strange reflections the universe hides from plain sight, then stay. Join this journey. Not just as a watcher, but as part of the pattern. Because curiosity, like gravity, binds us across every world. Stay with the forking point. Every discovery leads to another reflection. Every reflection leads to a new story. And somewhere, across the dark ocean of the cosmos, another version of you is already listening. What NASA found was not a planet, not a place, but a question. And that question still glows softly, waiting for us to answer.